Okay. All right. Okay. I've got a little timer next to me to make sure I stay on time. So yeah, here we go. So yeah, my name is Joe Davies. My email address is just here as well. I imagine these slides were made available to you as well. But if you do have any questions that we don't get to during this time, then please do email me there. It's my work email, so it's a little bit more efficient than just my personal one. And I will try and get back to you as soon as possible. I'm completing a PhD. I'm actually in my last year at the moment in particle physics with a focus on artificial intelligence. I do that at Queen Mary University of London, hence why I'm drinking out of my Queen Mary University of London mug. I worked in a handful of companies outside of university as well as part of the degree. One of these was a startup called Rewire, which I'm wearing the shirt of. I'm going to be shamelessly plugging them through this. I don't actually work for them anymore, but it was part of a temporary thing, but we still actually keep in contact because they're a very, very good company. They're actually made, or they're recognized as one of the top 100 companies in 2021 in terms of technology, specifically for content moderation, hate speech detection. This is what I used to use in my company photo. You may notice a slight difference between the amount of hair that I've got there versus now. I had it all chopped off recently, much to the delight of my mum. So there we go. So today we're going to be talking about the problem of hate speech, what natural language processing is and how it can be used to remedy hate speech, perhaps, the machinery of NLP as well, the process of content moderation itself, and then how that kind of ties into free speech and how you can get involved. I think we'll have some time for questions at the end as well, but if you do have any questions, please do put them into the chat, just because it means that we've got a nice little record, but obviously, you know, we'll be able to ask them as well, personally. I do have to put in a content warning. So we are going to broach, obviously, some topics today that aren't particularly nice. We're talking about hate speech. We're also going to be having a look at sort of slurs kind of every now and again, some pretty violent attacks on people as well, some sort of sexual language as well. Stuff that we won't go too in depth into this sort of stuff, but we do need to touch on it just to discuss this sort of thing. So this is your sort of warning for that. Don't worry, it's not going to get too heavy. It's just me letting you know. Okay, so let's just begin with the problem of hate speech itself. Now, hate speech, the term, is actually quite difficult to define. It generally means any speech that supports any sort of prejudiced views against an ethnic, religious, or social group, and anybody based on some kind of identity factor. You know, what gender you identify as, what your sexuality is, for example. It could be some kind of identity factor, what religion you are as well. And it's a global issue with reports of it happening on nearly every single continent. If you look at the top left plot here, and you'll find I've got all the references at the end that you can check out as well. This was from the Pew Research Center on behalf of the Council of Foreign Relations. This is a set of percentages of people that agree with a statement. People should be able to make statements that are offensive to minority groups publicly. The highest is the US, 67% of people believe with that statement. Global medium is 35%. So this obviously isn't great. Okay, this is a statement that ideally we wouldn't want anyone to agree with. But with the advent of social media, it's become a lot easier for people to spread this kind of hate. And indeed, beforehand, it was an awful lot more difficult for this sort of hate speech to be detected at all. It had to be sort of in the media or something similar to that. But with social media coming out, it's now become a lot easier with a lot wider reach. And this is a concern amongst many people, if we return to America for a second. In 2018, the Anti-Defamation League, which is a wonderful organization, put forward sort of these findings they had, where 59% of people believe online hate and harassment make hate crimes more common. We'll come to some evidence of that as well a bit later on. 22% feel less safe in their community because of it. 37% of adults have actually experienced severe harassment online. And 85% want governments and government bodies to act by improving training and resources for police on cyber hate. So this is something that people do want. Now, this is of growing interest, of course, to both host platforms and regulators, but it's not had the attention that it should have. Companies are saying they're doing more. So for instance, Facebook, if you look at the top right-hand plot here, will ask the question, how much hate speech content did you take action on? And you can see that from 2018 to 2019, sort of before 2020, you sort of peaked at around 5 million instances. And then during 2020, we have this massive spike, and yet that continues on for a little bit as well. So we have a huge sort of number of about 30 to 31 million content that was, hate speech content actions that were taken. And so you're thinking, well, okay, this is great. This is brilliant. That means that people are actually moving forward with this. But okay, but you have to look at the reason why this happened. In 2020, there was considerable economic pressure from companies like Coca-Cola, Pepsi, McDonald's, Nike, Sports Direct. An awful lot of these organizations said, well, you can't have this hate speech on your platform. You need to work to remove it. And so they did. So you can see that this is something that only now that there has been a little bit of impetus to change from economic pressure, we're now seeing people like Facebook, Twitter, and YouTube dealing with this. And you will know that YouTube actually sort of go kind of a little bit too far with it sometimes. TikTok is another famous example where now instead, for instance, of the ability to say suicide on the platform, some people have kind of jokingly, but not really, have started using the term unlife, right? Which has now kind of become a bit of a meme, which stops people from being able to make content about suicide prevention or drug harm reduction, because it's very difficult to talk about these platforms on YouTube and TikTok, for instance, because they just don't want that stuff on their platform. Now, solving this is incredibly important. So the first example I want to use is the Pittsburgh attacks. So for those of you who don't know, a man called Robert Bowers went in and shot up, I believe it was a synagogue, and killed people because of extremist views. Now, he was under the impression that a Jewish organization called HIAS likes to bring in invaders that kill our people. Can't sit by and watch my people get slaughtered. Screw your optics, I'm going in. This was not a tweet, though it looks like it, and it was made on a platform called Gab. Now, Gab is a bit of a white supremacist sanctuary. It's a bit of an alt-right sanctuary, but that's not how it started. Gab was started as a kind of attempt to make a more free version of Twitter, as in free speech-wise, okay? Which worked for a very short period of time. And then all those people that get struck on Twitter, so the very worst of the worst in terms of alt-right, just went over to Gab. And this post was actually made only a few hours before he went out and committed this attack. Now, you might notice here that Gab has that Robert Bowers, sorry, has a blue tick next to his name. That's because he was verified. So an awful lot of people actually saw this, and it wasn't taken down for a long time. This is not the only instance of this kind of hate speech actually begetting some kind of hate crime as well. If we look at Myanmar and the victimization of Rohingya Muslims, there's an awful lot of social media presence there where they call them insects, or they call Rohingya Muslims difficult people, or a problem, or a curse, or a plague. This same sort of language was actually used during the Brexit campaign, where we had those breaking point adverts, right? So social media has been used to fuel hatred. And then we have spikes in hate speech correspond to spikes in attacks, and certainly extremist attacks as well. If we have a look at the middle footage here, this is not a video that I sort of toyed around with the idea of putting the actual video on here, but I decided against it because this is actually the last moments of a Muslim beef smuggler in India. This video was posted to, I believe, Facebook and Instagram, and it was shared on WhatsApp as well. And this is a man actually being killed by an angry mob after it was found that he was smuggling beef into India. As we know, an awful lot of Indians, indeed most of the country, believe that beef and indeed cows are sacred animals. And so this was obviously not acceptable in the eyes of this mob. However you cut it, though, it's not acceptable to kill someone over this, right? And this was fueled by social media. If we have a look at discussion around and examples of hate speech posted online, alongside reports of hate crimes in the UK, we get something like the graph we find on the bottom right here, where you can see that there is definitely an uptick in reports of hate crimes when you've got a high volume of hate speech mentions. Okay, so we can see that there is really this impetus to reduce hate speech so that we reduce the amount of hate speech online. After the Brexit campaign, for instance, and after we left the EU, immediately after the vote even, the amount of rhetoric against, for instance, Muslims and any other minority in the UK went up by around about 400%, alongside attacks as well, which went up. Extremism is favored by platform algorithms. This may seem kind of shocking, but you would have noticed this already if you've ever been down a YouTube rabbit hole. It doesn't have to be the alt-right that you're going down this rabbit hole for. It may be that you want to get into exercise. So you look up how to properly run, or you look up Pilates videos, and you're just doing like a 10-minute yoga thing. And then suddenly you get recommended a video of, oh, you can do a plank for 10 minutes by following this every single day. And then you go further and further and further, and suddenly you're being fed videos about ultra marathons, Tough Mudders, and climbing 6 peaks in one day, and you know, ridiculous stuff like this. And this can be fine, as in the example of running or cat videos, but it can also take someone who is moderate, maybe sitting on the fence about certain opinions, and take them all the way down to believing in deep state and QAnon and things like this. So it is indeed very dangerous. Now, one way we may be able to utilize natural language processing is to stop this. So we need to actually know what natural language processing is. So it's a field of study that focuses on how computers can be used to analyze linguistical data. Okay, the ultimate goal for it is for an AI to be able to understand a piece of text as a human would. Now, we do need to sort of take a pause here and say that an AI will never be able to understand it in the same way as a human would, in the same way that an AI probably will never be able to understand emotion. In order for an AI to be able to understand this stuff as a human would, you'd kind of need to be able to hard code this ability. You'd have to understand it yourself in order to get the proper data inputs. But we can do a pretty good facsimile of this. We can do a pretty good approximation. Now, there are plenty of factors that come into play here. Think about just how difficult it is to actually understand a simple sentence. Now, for a human, this is intuitive. Language is most likely an emergent property of the brain, says Noam Chomsky in, I think, the 70s, who was a very prominent linguist, still is a very prominent linguist, one of my personal heroes, actually. But it's a very difficult thing. You have to consider grammar, you have to consider antonyms, you have to consider spoonerisms, portmanteaus, where a word comes in the sentence, the root words, the determinants, things like this. It's not a non-trivial, it's not a trivial thing, sorry. Now, examples of some tasks that natural language processing can actually accomplish: speech recognition. Actually, this I think this recording will have automatic speech recognition put upon it. And certainly if it's uploaded to YouTube, as with a previous talk I gave to Women Who Code was uploaded to YouTube as well, and it can have automatic speech recognition from YouTube as well. I've worked with some of this data, and actually, as a side note, YouTube speech recognition data is a nightmare to work with. It doesn't do punctuation very well. It can also be used for sentiment analysis. So there's you can do something called a Twitter scrape and get a lot of different tweets from online, and then you can apply some kind of sentiment analysis algorithm to see how people feel about Donald Trump or Pokemon or something else. A sort of good story I have about this is that a friend of mine was doing their training in data engineering, and they were doing sentiment analysis in Python, and they met up with me and said, "Oh, I have to tell you this, Joe, that we couldn't use English Twitter. We couldn't use British Twitter at all. We had to use American Twitter." And I said, "Why is that?" They said, "Well, because the Brits are far too ironic and sarcastic whenever they make any tweets, so we can't use it. It's not reliable as sentiment analysis." So, like, okay, that's really funny. It's great. So that, you know, be proud of that you can't be scraped. Content moderation is obviously one that we're going to talk about today, and is one of the more important ones, I think. Now, great algorithms actually already exist for this. So GPT-3, for instance, is probably the most powerful AI that we have on the planet in terms of natural language processing. It has about 175 billion tunable parameters, which is crazy. The model is huge. I've looked at sort of like how it's, there are algorithms that you can use to help visualize a neural network, for instance, and it is crazy big, but it is also very, very powerful as a result. It can read and write any language you put in. It can make its own programs, as in it can write in Python, in C, in Java, in whatever you want. And it can even suggest video ideas to content creators. So Tom Scott, who is quite a famous YouTuber, made a YouTube video where he asked an AI to create some content for him, and it came up with some pretty good ideas. I think one of the ones that you can see in that little graphic is what would have happened if the UK went to the moon instead of the States. So we have an awful lot of stuff that can be done with natural language processing. So we probably should talk about the machinery of NLP. So I'm not going to talk too much about the nitty-gritty of the coding today, and we'll come on to why in a second. But we do need to understand the background behind natural language processing. So there are a series of steps that you need to take. So first of all, there's segmentation. So I get a paragraph of text, and I want to split that text into sentences, and that's segmentation. I then have one of those sentences, and I take that and I tokenize it. I'm going to split that sentence into tokens. Is it word or is it a punctuation point? We then want to predict parts of that speech. So is that token a noun, an adjective, or a verb? You can see that being done on the bottom left here. Then we have lemmatization. We want to convert those words into their root forms, the same sort of thing that you do when you're trying to learn a language, right? So if I have daisies, that will become daisy. If I have is, that will become be, right? And I want to do that because I don't really care about plurals, not really. I may do if it's a word that I'm actually focusing on, but I want to focus on the very root form of that word so I can kind of understand the text at the sort of root level. We want to find stop words. We don't want to include things like and, the, a, that sort of stuff. And dependency parsing as well. How do the words in a sentence relate to each other? And you can see on the bottom right here that I think this is a really good representation of this. You can see that if we use the phrase, London is the capital and most populous city. London is our subject. It's a proper noun. We also have is, the root of which is be. It's a verb. It's an attribute as well. So we know that London is the attribute of our capital, the word capital, which is a noun. We have the, which is a determiner, and so on and so forth, right? So we have an awful lot of things that we have to consider. Now, your brain does this automatically, but we have to train an algorithm to do it. Then we have two of the sort of more neural techniques, the more interesting ones. Named entity recognition, NER. Now, the goal here is to actually extract useful information, tagging things like places, people names, dates, times, numerical values. When I worked for a company called Receipt Bank, we did this kind of thing as well, where we were looking at receipts and we used something called optical character recognition, which is a form of NLP, to pull out VAT paid, or how much money was paid for this coffee, or what item was paid for, who paid for it, what was the card number that was used, etc. And then it may happen, this is not something you have to do every time, but you may also want to do correference resolution. And that's essentially, we want to make sure the algorithm understands what entity each pronoun in the sentence corresponds to. So if I have a sentence that says the dog was so excited, it leapt up for joy, we want to know that it means the dog, right? Because what happens if we separate this into two sentences, the dog was so excited, it leapt up for joy. We want the algorithm to be able to not just separate these two sentences as we do in segmentation, but to make sure that there's a connection point between the two, which is our correference resolution. Now, these steps are done using different algorithms. Generally speaking, you have something called a tokenizer that does most of 1 to 6. And then the steps listed above will be the domain of some kind of deep neural network. And we have a full natural language processing pipeline at the end there. Now, this is an interesting point. All we're doing here is deep neural nets. When we have tokenization, all we're doing is we're assigning a numerical value to each word or punctuation mark, because we are just feeding in a numerical value to a deep neural net. An awful lot of these networks have already kind of been made. And we can use common methods and libraries for these. So common methods of tokenization are term frequency inverse document frequency, or TF-IDF, which is utilizes the how many times a term comes up in a document, and also how many times a term comes up in a series of documents. You usually use a corpus of documents. So a good example that I sort of came up with before this talk was raspberries, right? So I've got a document and I want to find out if it's about raspberries. So I have a look and see how many times the word raspberry turns up in this document. And if it turns up a lot, you sort of go, okay, well, this document is probably about raspberries. But let's check to see if this document is specifically out of all these other documents pertaining to raspberries. So we have a look at the rest of the documents in our corpus, in our little collection, and we see, okay, well, the rest of these documents, they do not talk about raspberries at all. Therefore, this is a document I want to have a look at if I want to learn about raspberries, right? We can also use something called byte pair encoding, or BPE, which looks at how often pairs of characters appear together in vocabulary. And indeed, it creates its own vocabulary. So you have a look at a pair of characters, you see what's next to them, you have a look at a pair of pairs, and then a pair of pairs, and so on and so forth, until you create a vocabulary. This may seem confusing, but if you imagine that you have the word to, so just T and O, if you have a look at the pair TO together, if you're lucky enough that your algorithm immediately identifies those, it will also have a look at O and the character that's next to it. Well, the character next to it is white space, it's a space, right? And the character next to T is also white space. So it then goes, okay, so this must be a word of its own right, too. And it continues on through that. Now that's tokenization. Common methods of understanding a piece of text, those neural methods after it's been passed, are bidirectional encoder representation, so BERT. This is kind of like the bread and butter of most of natural language processing neural methods. And these are trained to predict what a piece of text is referring to or labeling specific tokens. So is this piece of text about raspberries? Is this word raspberry? Does it pertain to raspberries? That's what you're using BERT for. If, however, you want to have a look at something a little bit more interesting, a little bit sort of more advanced, and you want to be able to predict what the next token will be, right? Or you want to, create your own comment or news story, news article, then you want to use something like generative pre-training, so GPT-X. I say X because GPT-3 is not the only one there. There's GPT-1, 2, 2J, 1B, all these different variants. Now they're trained to be powerful about prediction, right? So GPT-3, for instance, unless you're sort of trained, unless you know what you're looking for, can make entire news articles that really you wouldn't really be able to tell from the real thing, from a human writing it. I had a friend of mine who just after he finished his PhD, he managed to get some time on GPT-3, you have to apply for it. And he plugged in a bunch of physics papers, scientific papers, and had GPT-3 write its own scientific paper. It was about 17 pages long and was pretty good. It was pretty good. Almost entirely incorrect, but it used the right terms and it was, it was nice. It was pretty good. Now, it should be noted that any of these neural methods, as I've said previously, are just neural networks. I say just, but if you learn how to code a deep neural net, you kind of know how to code one of these. And these are the same things that will do forecasting or statistical analysis or computer vision, right? Because we're still using numerical data, really. It's just that we have to start with words, first of all. Now, common Python libraries to use are Hugging Face. Hugging Face is awesome. It's really good. I've got a link at the end of this to Hugging Face's sort of main website. It has loads of pre-trained models and loads of pre-trained tokenizers and examples. When I went for the interview for Rewire, I actually ended up using Hugging Face for the sort of the interview tasks. They recommended it to me. And it's wonderful, really, really good. I cannot recommend it enough. Spacy and NLTK are also very good. Some of these are better at dealing with more sort of difficult things like I said, YouTube captions, not great, really sort of difficult to segment them in a kind of clever way. I know because I once spent like 2 days doing it and it's a nightmare. But these algorithms and these sort of these libraries are what I use to do so. Now, as in all of machine learning, we do need to have some kind of way of measuring how well you're doing. In a lot of deep neural networks and things you've already heard about before, you'll have things like minimum squared error and error analysis based on using like gradient descent and things like that. for natural language processing, we can use often precision, recall, and F1 score. So precision is the ratio of true positive and sum of true and false positives. So this will give us the percentage of positive cases from total predicted cases. So for instance, if I say that the positive case, which doesn't necessarily mean good in this context, just means it's positively defined as hate speech, then what I'm looking at is how many of the things defined as hate speech are actually hate speech, okay? So the true positive is the actual thing that we want to find. The false positive is a mislabeling. So it's something that isn't hate speech, but has been now defined as hate speech by the model. Now, recall is the ratio of true positive and the sum of true and false negatives. So this will give us a percentage of positive cases that are predicted correctly. So false negative should actually be a positive, right? It's a false negative. It is something that is hateful, but has been identified as non-hateful. So we want to find out how many of these are actually predicted correctly, not just how many of the predicted hate speech are we actually finding, as in precision. Now, F1 score is something called a harmonic mean and the combined result of precision and recall. So a harmonic mean is where we have the number of variables we have, so precision and recall, so that's 2, divided by the sum of the inverse of these variables. And that's what we have at the bottom there. Now, this can be used with some averaging technique to get an overall idea of how well the model is performing. So for instance, in a hate speech model, maybe you're focusing on misogyny, homophobia, racism, and you've got all 3 of those, and you take the scores from precision and recall for all of those, you take the F1 score for all of those, you add them all together, divide by 3, and you've got your macro F1 score, okay? But maybe one of them is something that you want to focus on. Let's say, for example, you run Women Who Code, okay? And you find that you want to perhaps weight towards misogyny because you find more instances of it in some kind of comment section that you have, right? That's not necessarily something you're not going to find. You know, people are going to probably target an organization built for women with misogyny, okay? So you weight those a little bit more. So you have a weighted F1 score, okay? That's not to say that you're not going to do anything to do with racism or homophobia. It just means that you expect one type more than the other, right? So data, always the most important thing whenever it comes to machine learning, and is specifically important for natural language processing. For numerical data, such as what I find in physics or what you may find in forecasting, the model is really what you want to tweak because the data is numerical, it's just numbers. You can order them pretty much however you want and it's okay. You can shuffle that around and it doesn't matter. You can't do that with text data, right? You can't just shuffle a sentence around and have it mean the same thing. There is context there. Excuse me. And linguistic data is difficult to understand because of that context. So I'm going to give you an example. So even GPT-3, the most powerful bot on the planet, cannot answer a simple question like this. The council were afraid of the protesters. It was thought they could get violent. Who are they? Now, any of you are probably already going, well, you know, they are the protesters. If I asked you why, you'd say something along the lines of, well, fear is something that you have for only a specific number of things. I don't know about you, but I'm afraid of violence. I don't want to get hit in the face. So I could be afraid of the people that are going to be violent, right? If the council are afraid, and it was thought that one of those two could get violent, it's probably the protesters that are going to get violent, right? Because the council are the ones that are afraid of the violence. But what happens if I change this around? Because what happens if I say to you, well, actually, they refers to the council? Well, now you say, well, I can rationalize that quite easily. Because if the council are afraid of the protesters, it may well be their response is to get that violence immediately out of the way, pro-retaliatory violence, right? Something that is not necessarily warranted, but it's still a response to protesters that are there, right? So it could be the council getting violent because they're afraid. That's a response to being afraid. If I change it to the police were wary of the protesters, it was thought they could get violent, and you give that sentence to, say, a BLM protester in the US, it may well be that that BLM protester will say, well, they, in this instance, absolutely refers to the police. If, however, you say this to a police officer, it may well be that they say, well, actually, I'm saying the protesters are the ones that could get violent. Context matters, and it's intuitive for humans, but you can't really teach intuition. It comes with practice. So that's what NLP algorithms can have a problem with. They can also have problems with sarcasm and irony, as I said before, uncommon languages. So we have in the West the benefit of having the money and the equipment to be able to make NLP algorithms, but it may well be that there are languages that we don't come across very often. For instance, I went to university, in Tower Hamlets in Queen Mary. There are an awful lot of languages spoken there. I had Iranian friends, and sometimes even Iranian people wouldn't be able to speak to other Iranian people in the native language because not everyone speaks Farsi, right? There's a lot of tribal languages that they speak. So it may be that there are uncommon languages like this. There's also domain-specific language. So if you have a look at this comic at the bottom here, sir, we tweeted the bit.ly to the vlog. When our tweets retweeted it, it went viral. And the manager, no hablo español, don't understand you, right? So this is something that you may well be able to understand. You know what a tweet is, you know what retweeting something means, you know what something goes viral, but this is domain-specific language, okay? When I was working at Receipt Bank, I was on a green field project. I was doing a lot of blue sky thinking, right? There's a lot of business jargon that comes into that natural language processing algorithms have to kind of consider. And what about slang and colloquialisms? I live in London. I've lived in London for 8 years. If someone were to come up to me and say, bruv, that's peak, I know that means, friend, that's bad, right? But it may not be something that an awful lot of people understand if they're not from this area. And we're also heavily biased towards these Western languages, as I've kind of explained. Arabic, for instance, has around 300 million native speakers, but in Receipt Bank, when we were trying to get Arabic and Mandarin Chinese and the Cyrillic alphabet as well for Polish and for Russian as well, we found it quite difficult to train our algorithms to do this because we've trained them with an alphabet initially that was English or German or French or Spanish, okay? So it's something that companies only really aim to solve after they have algorithms that can understand English, right? Because those are the common ones they're probably going to deal with in reality. And whilst the Arabic alphabet, for instance, is very beautiful, it's not something that people in the West will come across very often. So we have to make sure that we understand that. Okay, so we have a pre-trained model, okay? Now that pre-trained model means that we've gone through the process of annotating a data set, which means we've hired some annotators to say, this is hate speech, this is not hate speech, depending on some community guideline, right? We've fed that fed that data set into our model. So we've trained it. NLP algorithms for content moderation are by and large supervised algorithms, so they will already have an answer that they like. And we trained that model, it's ready to go, it's all done and dusted, and so we attach it to our website. So identification is the first step. A text or image is flagged as possible hate speech. Remember, natural language processing can actually be based on text on an image as well as just spoken word or written word. But this is based on some platform-defined rules. So maybe you are a moderator on Twitter, so you have quite lax rules on hate speech and content moderation. But maybe you were playing Club Penguin, the kids game back in the day, and you recognized that you couldn't even call yourself poop, right? You have a very stringent set of content moderation rules. And it's usually done by some user or moderator. You see the flag button on tweets, or if you are on Reddit and you're a moderator, you can flag posts as being bad. Then we go on to verification. So it's passed on to the NLP algorithm. Now, sometimes it's flagged as hate speech and just automatically removed. However, sometimes you only have, say, 60% security that it's hate speech. And so the algorithm will say, I'm not sure about this. So let's pass it on to a human. And this is known as human in the loop. It's the industry standard at the moment for an awful lot of things, certainly for something like content moderation. You have a human that does something if we have only, say, 60%, 70%, some kind of level set by the user, or sorry, the company. And that human will then verify that it's hate speech or not and remove it, right? This is something that at the moment with big companies like Receipt Bank, there are companies in India, for instance, that will handle this for you, or there's big companies in Eastern Europe that will do this for you as well, because this is something that's super busy. So we want to improve these algorithms, so we don't necessarily have to do that. It's quite expensive to do that. So it'd be good if we had better and better algorithms. So it's great that you're here, because it means maybe you can create those. And then the last step is some kind of action is taken. So if something is found to be hateful, the post can be removed, the tweet can be removed, the comment can be removed. And you can also warrant someone a punitive measure. Maybe if it's an online game, for instance, they can be muted in the chat box. Maybe they can have their account suspended. And if it's a repeat offender, accounts may be investigated by the police. You can actually have, and I'm sure you've all heard of stories of people being cyberstalked, for instance, right, or doxed. And those people are actually found to then have to deal with real life consequences of this. And there are a lot of issues facing this kind of content moderation. The big one really is contextual collapse. So there are so many demographics in online spaces that it's difficult for any post to be entirely inoffensive. Now, I don't have Twitter anymore, but when I used to, maybe I'm hanging out with my mum, my little sister, and my grandmother, and I post a picture sort of tongue-in-cheek that I know that my mum, my sister would find funny. Grandma's never going to be on Twitter anyway, and I write, "Great day out with these bitches," right? Now, my mum would find that funny, my sister would find that funny, most people that I know would probably find that funny. But if I had enough followers and it's retweeted to people I don't know, people could quite rightly take offense to the use of the word bitch when it comes to the people in my photo, especially if they don't know that they're related to me. So looking at a post in isolation may not give the full picture, but unfortunately, a lot of people can only do that. Yes, it can be a hateful statement if I write a tweet that says, another Holocaust would be a great idea. If someone responds to that with, yes, it is, that is itself a hateful statement. And people are great at getting around content filters as well. Intentional misspellings of words. There are honest mistakes, of course, but people can make those mistakes on purpose. Using synonyms that have no adverse meaning. One of the things that we used in Receipt Bank was we were training on emojis. So after the Euros in 2021, some of our own England players by English people were sent emojis of like monkeys if they were black. Because of the obvious connotation there, right? Which is obviously unacceptable, but it is another way of getting around content moderation software. Now, this can be mitigated against using augmentation libraries. So you can have libraries like NLP.org for Python that actually simulates some kind of common augmentation. So maybe someone's finger slips onto a different key that's close by. You know, T is quite close to Y, for instance. Maybe people use synonyms, or maybe you translate into one language, then translate back. It's called back translation, and you lose something in the context there. There's also slur reclamation. It's really good that we're in sort of like the women who code context, because women are fantastic at reclaiming slurs used against them, right? The word bitch. Plenty of women use bitches as terms of endearment, or hoes as terms of endearment. Having mimosas with my hose has been a tweet that a friend of mine sent out a couple of times, right? So these are things that people often reclaim. For instance, I can't train an algorithm on just the N word, right? Because an awful lot of people will use it as a term of endearment. NWA is an entire rap group that used it in their very name. So you can't just train an algorithm on slurs. And language constantly changes. Good example of this. Let's go Brandon never had any connotations before the phrase let's go Brandon was used to mean fuck Joe Biden, right? And that took off. But now you kind of, in some cases, have to look for these really weird statements and phrases that were now used as indicators of the alt-right, right? The whole Pizza Express scandal has now been used to talk about child pedophilia and things like that because of Prince Andrew and all this sort of stuff. Tay tweets is a great example. So Tay tweets was something that was used as a way of trying to understand, it was an AI, it was a bot used to try and understand how millennials speak, and so you could tweet at it and it would learn as it went on. So it started out on the 23rd of March in 2016 with tweets like, here's a question, humans, why isn't hashtag National Puppy Day every day? Very cute. About 5 hours later, we got tweets like, I effing hate N-words. I wish we could put them all in a concentration camp with Ks and be done with the lot. So humans are very good at not only circumventing it, but training things to do this. We do need to talk about free speech here as well. So free speech, ever heard of it, right? To be clear, and just to make sure that we're all on the same page, free speech is about your ability to say what you like without fear of retaliation, censorship, or legal sanction. But, big but, this does not extend to the incitement of prejudicial hatred or violence towards a protected group. And that is an important distinction to make. If you take away the word fuck from our lexicon, you also take away the ability to say fuck the government, right? And that's a very important thing. For example, I hate fat people is offensive, okay? It is offensive, but it is not hate speech. So it would get through most hate speech filters, depending on whether on the kind of platform. If, for example, you run a blog or a website that does an awful lot for fat acceptance, for instance, then you may actually have that be removed automatically. But that's up to you, and it's not an infringement of free speech to say that. But if you're in a public sphere, that is not an example of hate speech. You can see that the comic on the right here is from Ben Garrison. He is a right-wing cartoonist, gets things wrong an awful lot of the time, very sort of boomer comic. And this is free speech monopoly. Make sure, guys, that you can play the hate speech card. This is the kind of ridiculous thing that we get when we take free speech and the kind of discussion of it a bit too far. Now, ultimately, it's up to the platform and the company performing the content moderation to decide what actually constitutes as hate. And this involves and is reflected in how annotators are instructed to define a statement of hate when we do this data acquisition. Noam Chomsky, for instance, says, if we do not believe in freedom of speech for those we despise, we do not believe in it at all. For instance, if we return to the I hate fat people example, whilst I don't agree with the statement, and you should not go up to people who are overweight and say, I hate you because you're fat, unfortunately, because it's not hate speech, and because it's not an infringement of free speech to say it, there is an impetus to defend the people who say it, right? On the basis of course, that it's not hate speech. I'm not defending people saying that. Please don't now go out and say that. Okay, so after all this and the kind of sort of some of the difficult talking points, how can you get involved in this? And you should absolutely get involved in this. Well, you can try some examples. So Kaggle.com, which I've mentioned in the last talk as well, has some great examples. So one of them from Matt Leonard has an intro to NLP. It's a notebook that you can follow along with, especially if you code in Python. You can read some literature. I've linked a PDF, which does a great talk on sort of natural language processing and indeed content moderation. Look at what the state of the art is. So like Hugging Face, things like that, libraries like that. And have a look at some companies. So this is where we bring in the shameless plug for Rewire. Like I said, I no longer work for them, but I'm still in contact with them, actually meeting up for drinks next week. And if you have a look at some of the companies at the bottom, we have Microsoft Azure, we have Perspective, which is Google's content moderation software, and we have Rewire. Now, Rewire actually outperforms these two. And if you're interested in having a look at Rewire and the content moderation platform that it provides, they have something called Rewire for Social Good. So if you're starting a community space, for instance, if you're starting a safe space to discuss certain things, if you're starting, say, a charitable organization that looks to protect people from certain elements of, say, domestic abuse or something like this, Rewire will offer you discounts on the products or even the product for free, depending on the context, in order for you to get that up and running, which is a wonderful thing, I think, for them to do. So if you have any questions, please do let me know. This is the references that you can use. You're more than welcome to take down any of these and ask me about all of them. I think they're wonderful organizations, especially Ditch the Label. That's a great one that I pulled a lot of stuff from for this. But yeah, that is the end. let me get any questions from you guys. I'm going to stop sharing, I think.
Thank you so much, Joe. I think we have some questions in the chat.
I'm going to scroll up now, I think. Here we go. There we go. Okay, so do you mind if I just read out some of the stuff in the chat? Is that cool? Yeah, great stuff. Okay. Yes, so that said, so Hassan says, that said, the AI can also not respond in anger to being called a racially insensitive term. Absolutely true, right? So this is the kind of one of the benefits as well of using AI. So I talked about data acquisition and how that pertains to annotators. So Facebook actually came under fire for, I believe it was their operations in Kenya, where they weren't giving annotators adequate mental health support. And indeed, my flatmate, actually, I got her a job in doing annotation for Rewire, and another friend of mine as well. They give you specific mental health days because they understand that annotating an awful lot of things, especially since one of the big focuses for us was misogyny, because it's just so difficult to identify, like I said, because women are fantastic at reclaiming these slurs, that they do need these kind of mental health days, just because it can get really hard. I think one of my jobs, which was fun and not fun in different ways, was I spent a day typing in the most horrible things I could think of into our algorithm to see how well it performs and comparing those to some annotations that we had. So some of these can be really horrible. Some of them are comically horrible, as in I don't know how you've possibly made that wild leap of imagination about this protected group, but okay. So yeah, this is absolutely true. And the AI would be a great way of doing this if we could do that, right? Yes, let's have a look. Irina asks, do people combine several methods for one text? Yes, we do, absolutely. So you may find that, for instance, you have something like optical character recognition. So you want to use maybe OCR for that, or you might want to use CNNs for that, convolutional neural networks, and then take that information and feed it into a NLP algorithm. You may also want to use a specific segmentation algorithm for, say, YouTube captions. And then once you've segmented that paragraph into sentences, you can then use TF-IDF or something like that, or byte pair encoding. So you can combine those two. Absolutely right, Yang. Every PhD's dream to have a GPT-3, 100%. It's difficult to get the time at the moment, but oh man, it would be awesome. I would have to really plan out my time with the GPT-3 algorithm. That'd be great.
It'd be nice to have the formatting, and then you just fill in the words between them and type in the figure.
Yes, Hassan, brilliant. Thank you for answering this. Yeah, Irina asks, what it means if the score is 1? Yeah, it's a statistical certainty. So you definitely have, if your score is 1 for F1, for instance, you know that you're doing very well. Your model is doing very well. If it's precise, if it's got a precision of 1, you know that you are getting all the positives. If you've got the recall is 1, you know that you're not getting any false negatives. So that's really good. Can we use NLP for our mentorship program? How much data do we need to train models and watch and to match mentees and mentors? It depends. I mean, an awful lot of the data that you have, you just don't want to stop taking it. If you've got a lot of data, you've got a lot of data. Flood your algorithm with it. More data is always, always, always good. I would say that we did an awful lot with a few thousand comments. So that's mostly what I worked with, but that was a subset of data, and that was just the testing data. So when we actually trained the algorithm, we did so on tens of thousands of comments. So that's probably your better option. The more data you can, the more documents you have, just save everything. Junk data is not junk data. For instance, when I worked for Receipt Bank, I managed to make an algorithm that did user segmentation. So it wasn't NLP, but it was taking our entire user base and putting it into like 5 different groups that you can advertise to differently, using stuff like what buttons do they press on the site, how much time do they spend on this one web page, stuff that you'd usually throw away, but actually it's all of this stuff is really good. What is GPT-3? So GPT-3 is an algorithm that came, it's a pre-trained algorithm that came from, let's make sure I get it right, OpenAI, which is an organization that is founded by Elon Musk. So unfortunately, this guy is like the Edison of his time, which means that he provided space for a lot of inventors, and GPT-3 has come out of his space. He didn't really have much to do with it. It's more that he provides the money for this to do that. But GPT-3 came out of this. It is a huge model. So when I say 175 billion tunable parameters, if I have a deep neural net with like, say, 10 input features, 100 neurons, and then 2 output features, I would have what? 10 times 100, so 1,000 times 2, so 2,000 weights, plus I think it'd be about 2,000 something weights, right? This doesn't have 2,000 something weights. This has 175 billion parameters, tweakable parameters. It's crazy. So this is a huge model, and the more parameters you have, the more data you need to train, right? You need billions and billions of data points. So it used supercomputers to train this. But once you have the model trained, you don't actually need a lot to mount it, okay? It's good, it's quite easy to do that. And I'm dreaming about using this algorithm because it's crazy. So for instance, Google Translate uses a sort of a smaller version of this algorithm where this is actually really cool. And I could talk about this for ages. You can imagine I'm very into all this sort of stuff. But if you have something that is translating from one language to another with Google, it translates it into an intermediary language, which only the computer can understand, and then translates into, say, French from that, if you're going from English to French, right? Now, GPT-3 does kind of the same thing, but we don't know what language it creates as an intermediary. But it can understand French, even if you've never fed it French, by just kind of understanding the grammatical structure and then translating. It is a crazy, crazy algorithm. It can write its own Python code. It can write, it's not just hello world either. It can design code and things like this. It's one of these algorithms that, for instance, engineers now use to make PCB boards, because there was a very famous example of a PCB board that was designed that engineers said, no, this won't work. The algorithm is rubbish. But they made it anyway, and they found that there was an extra wire they'd put into the board that they had no idea why it was there, but the wire had just enough of an electromagnetic potential difference in the field around it that it can induce a signal in another component. And so it was a more efficient way of transmitting an electrical signal. This is the kind of thing that some of these really huge algorithms are able to do. It's stuff that we would never think of. Yeah, it's crazy. How do the models used by Rewire Perspective keep up with the slurs being reclaimed and the new ones that crop up? Great question. So the way that we do it is that you continually train, but what we did in Rewire is we had our own data sets. So you don't just take stuff, there's very famous data sets like Davidson, Bazile, a lot of these different data sets that are hugely famous that are kind of like the hello world of natural language processing. What we did was made our own templated one. So you had, I hate pizza, I hate burgers, and then you go on to the hateful stuff like I hate Jews, I hate brown people, I hate, all this sort of stuff. So you have this templated format, and what you do there is you remove an awful lot of the quote unquote noise from the samples. So if I make a tweet that says, I had a coffee today and I was just thinking about how much I hate Jews, right? You don't really care about I was having a coffee today and I was thinking about. You care about the bit that says the offensive term, right? That's what you care about. So that's what we focused on. Perspective aren't doing that. They are kind of starting now because they bought they bought a piece of software that we benchmarked against, and because we proved how bad that software was, and we just happened to know the people that made that, so I'm not going to mention the software's name for fear of litigation, but we showed their software was kind of bad, and they actually went, oh, okay, that's great, we'll take it down. So it's something that you need to consistently do. You constantly take in new slurs, take in new reclamations, and retrain your algorithm with those. So there's an awful lot of people that will, I mean, you'll update your algorithm anyway as soon as new things come out. People are always updating their algorithms because it's a good idea. So you basically just have to keep on top of things. That's kind of the only way to do it, unless you have a really, really powerful algorithm like GPT-3, which can just sort of do it. But that's a showcase algorithm. It's not really something that you can use in a commercial setting because it's just so difficult to make. Okay. Oh, that's cool. Previous fund also invested a bit into OpenAir. Yeah, great. Do it. Emma asks, I'm building a discussion system that uses perspective for light auto moderation, but rewire for social good sounds interesting. In what ways does rewire outperform perspective? Yeah, so again, so has someone answered this in a partial way as well? One needs to constantly monitor and revise. Yeah, you would need to monitor this, but rewire outperforms perspective on every measurable metric. I'm not just saying that because I'm an evangelist for the company. I'm saying that because I measured it. So it's every single measurable metric, rewire outperforms perspective. There are benefits to perspective, obviously. They have, they're more, well, I'm sure there are benefits to using perspective. But rewire is really fantastic. Rewire of social good is a great one. It's very new. So this is why you may not have heard about it yet. And certainly rewire is still kind of in its startup stage. So if any people do work for any VCs, and it would be a great one to do. So I would recommend the social good initiative from Rewire if you are already using something else. Especially actually if you're using it for light auto moderation. Rewire has got a lot of kind of free examples and trials that you can use for just a few examples that you want to run on. So yeah, definitely recommend that. Okay. No worries. Well, I'm telling about our mentorship program, there's about a couple of dozen applications last season. So there may be a little bit of difficulty, but definitely doing a lightweight algorithm like BERT would be pretty good. You may be able to use a small data set like that. It depends how many words you actually have. So that's also a good one. It depends also on the what part of that application is important. If the entire thing is important, then great. But if it's just a few terms, it may be a few too many. I know a lot of VCs around the valley. Please take down my email and help them arrange a call meeting. Hey, great. Yeah, thank you. Feel free to, I'll put my email in the chat, but feel free to, send me an email and I'll certainly get back to you. Yes, yeah, more description from them for sure. I think that's all the questions we had for now. I don't know if anybody has one, but yeah, great.
All right, thank you so much, Joe.